Welcome, welcome, welcome. So day 10 of Just Start Programming, the Rust programming language. Yesterday we have gone through common collections, so maybe we'll just go through quickly for us to remember what we have covered yesterday before proceeding with error handling. All right, so common collections. Yeah, so there are three data structures for common collections: vector, string, and then hashmap. So vector, you'll have a variable number of values next to each other. String, we already encountered string before, so it's a collection of characters. And string is also similar to a vector in some ways. Hashmap allows you to create to associate a value with a specific key. So it's a key value kind of mapping. All right, storing list of values with vector. So vector can take in data types. In this case, it's signed integer 32, which is the default for a number. And then you have this new constructor. There's also this macro for a vector where you can straight away assign values inside the vector. So this one is not explicit, but by default it takes in I32. Okay, so how do we update a vector? If you define it like this, where you have the mutable, meaning this variable can change, you do a new, and then you can call the push function. It will push the values in sequence. So V will be containing 5, 6, 7, and 8. How do we read elements inside a vector? So here you can access the index, so it follows the same indexing number as an array. Or you can also call the get function. By calling the get function, you'll get an option, so you have a way to make use of match if there is some value or the index here doesn't have a value. What else do we have here? Okay, so in cases where you're accessing an index that is beyond what exists here, for example 100, in this case it says it will cause the program to panic. And there's a better way of doing it, which is this one. You get you use the get function. So get I would return an option, and then you can do some, it's like error handling also. You can check if there's no value, then do something, or if there's some value and you can do something. Okay. Yes. So best practice, you use get instead of doing it like this. What else do we have here? V0 push 6. So in this case, there will be an error because here V is a mutable variable while first is not mutable. But then inside V, where first is referencing this vector, V is changed. So in Rust, it ensures that you cannot do this kind of operation because vectors put values next to each other in memory. Adding a new element, yeah, so this is one of the key concept here. So they need to be next to each other, and adding a new element onto the end of the vector might require allocating new memory and copying old elements into the new space. If there isn't enough room to put all the elements next to each other, where the vector is currently stored, in that case, the reference to the first element would be pointing to a deallocated memory. Yeah, because in Rust, it will try to place this in sequence next to each other. So if you add 6, it has to be next to 5. But if it so happens that the next memory is occupied, then everything will be moved somewhere. And then 1, 2, 3, 4, 5, 6 is recreated there. So essentially, V will be pointing to another location in memory. However, first is pointing to the old location. So now first will be pointing into a dangling. Yeah, so it will be dangling in the memory. Okay, iterating over the values in a vector. You can use for loop. So V here is immutable, but we are referencing the value of V. So we're just borrowing V. And then I, so it will be stored here in I, and then we are displaying I. You can also iterate over mutable references. Yeah, so in this case, it's mutable, so it means that at some point we have the capability of changing the value inside V. So to do that, you have, okay, originally you have the ampersand sign, so it's still there, but we insert mut for mutability. And then there's this concept of dereferencing, dereference operator. So that will be covered in chapter 15. Dereference operator. Okay. Using an enum to store multiple types. So this is one way where a vector can contain multiple types by using enum. So it's like you're wrapping it inside an enum, but an enum will contain different types. So vec, at a higher level, I think it's seeing this as spreadsheet cell. then the value is this type. So Rust, if it allows vector to hold any type, there would be a chance that one or more of the types would cause errors. The operations performed on the elements of the vector. So we must also be explicit about what types are allowed in this vector. Okay. Dropping a vector drops its elements. Okay, so here, if it goes out of scope, so vector is dropped, and then the elements are also dropped. Okay. So much for vectors. Then we move on to strings. Yeah, so we have encountered string before, but here I think there was an emphasis on UTF-8. It has something to do with the size. I remember it correctly. So for Unicode characters like this, so the first character is actually 2 bytes. Okay, so this is how you can push or append into the string. You can do a push str, S1, S2 is bar, so S1 push str S2. Push str method took ownership of S2. If push str method took ownership of S2, then we won't be able to use S2 anymore. But there's a special behavior here. So push method takes a single character as a parameter and adds it to the string. Using push. Wait. This code works as we'd expect. Yeah. But what is the reason behind it? I already forgot. No push. Didn't say. Okay. Okay, here. The push str method takes a string slice because we don't necessarily want to take ownership of the parameter. Okay, so it takes a string slice and it doesn't take ownership of the parameter, so this code will still work. Okay. Then here, you can use the plus operator to concatenate like this, but you need to have a reference to S2. But S1 is already moved. So I think at some point there was an add generics, which we will learn later on, chapter 10. But I think it says here, this is not how we would want to concatenate things, although that is possible, because it gets messy later on. So I can skip this. Yeah, like this. At this point, S will be a tic-tac-toe. Difficult. It's difficult to see what's going on. So for combining strings in more complicated ways, we can make use of the format. and then we do it like this. So it is much easier to read. Yeah. So this is another best practice. Indexing into string. Yeah. Okay. So here it doesn't always follow that index 0 is character H, because in Unicode or UTF-8 like this, it is not applicable to this, because you'll have 2 bytes. It will look like this. So in total, 18 bytes for this character. So slicing string and slicing string, rather than indexing using square brackets, I think it's not a good way to, although it was introduced in the early chapters, we can slice string like this. I think only for ASCII, but for Unicode, we shouldn't do it like this. So there's a better way of doing it. Yeah. You can extract the characters, or you can extract the bytes. So it will print 4 bytes. This. It didn't show us how we can get the first one, actually. Car. Oh, this is cars. Probably there's a car, and then a number. Oh, but it was not mentioned here. So erase that. Let's just say we learned how to extract the values like this for now. Okay, strings are not so simple. Yeah, that's true. Okay, let's move on to hashmap. So it's a key value pair. There's a hashing function. So it's known as, I think in some programming languages, like hash, map, object, hash table, dictionary, or associative array. How do we create a new hash map? So there's a new function here. And scores is mutable so that you can insert. So in this case, it's string and number. And hashmap, although it's in standard library, but we need to use this keyword and specify it explicitly under collections hashmap. And why is it that we have to do this? I think something was mentioned here the other day. All the keys, selection standard. Okay. In the features brought into scope automatically in the prelude. It's not included in the features brought into scope automatically in the prelude. Okay, so maybe prelude will be mentioned somewhere in the coming chapters. Accessing values in a hash map. Okay, so here we inserted key blue, 10, key yellow, 50, then team name string blue, so team name. Okay, getting the key blue. which is a reference to team name. And then dot copied. What does dot copied do? Is it mentioned here? Dot copied. Okay, values are copied into the hash map on values like string. Okay. For types that implement copy trait like I32, the values are copied into the hash map. For own values like string, values will be moved. Okay, but it didn't mention anything here. Here. Handles option by calling copied to get an option I32 rather than option at. It's a reference of I32. So it copied the values, the value. Then unwrap or to set score to 0 if scores doesn't have any entry for the key. Okay, so it's like returning 0 by default. So whatever that is copied, if it's empty, then it will return 0 by default. And not empty, but if it doesn't have an entry for the key. Okay. Ownerships. Hash maps and ownerships. New map insert field name, favorite color, field value blue. Okay, here field name and field value are invalid at this point. Trying to use them, see what compiler error we get. Field name and field value. Insert. Plus the issue. If we insert references to values into the hash map, the values will be moved into the hash map. The values that the reference point to must be valid for at least as long as the hash map is valid. Validating references with lifetimes. Okay. So it didn't show how this can be fixed. I think if you put ampersand here, will it fix that one? What did we do yesterday? I did put ampersand here. So field name can be used, but field value cannot be used. Okay, run this to check once again. Field name, favorite color can be used. So if you remove the ampersand sign, so there will be a compiler error. Field name has a type string which does not implement a copy trait. String, in this case, it will be moved. Field value will, because we did not put ampersand sign. Okay. Updating hash map. You can overwrite a value. Okay, so the hash map will contain only one key value pair. Blue 10, blue 25, so scores would be blue 25. Adding a key and value only if a key isn't present. It's usually the case. Here, okay, we're inserting blue 10, yellow, or insert 50, blue, or insert 50. So, or insert, how does it function? If that key exists, and if not, inserts a parameter as a new value for this key and returns a mutable reference to the new value. If exists, or if not, insert 50. If exists, or if not, insert 50. Maybe that's how we should read it. I don't know. Yeah. That key exists, and if not, or insert the value. So I think it's a bit confusing. If the key exists, and if not, then I think if the key exists, or if the key doesn't exist, or insert 50. Oh, that's even more confusing. If that key exists, and if not, so, and if not, or insert 50. If that key exists, use the value, or if not, insert 50. I think that should be how we should read this one. If the key yellow exists, or if not, insert 50. If the key exists, if the key exists, and if not, or and if not exist, or insert 50. It's still confusing. Let's just stick to what should be the function to be called here. Yellow, if it doesn't have a value, then insert 50. If it has a value, use that value. Or else, insert 50, maybe. It should be the one, entry. Updating a value based on the old value. Okay. So I think we had, yeah. So we also have the dereferencing. What's it called? The same? Yeah, dereference. Dereference, because we wanted to change the value because of mut. Text split white space in Word. Map entry Word, or insert 0. So you'll have world. Yeah, it's not in sequence. In this case, world was given the value 2 since it's the second word here. So if you don't have anything, then it will insert 0. Hashing functions. Okay, so zip hash. By default, it uses zip hash. but you can switch to another function by specifying a different hasher. A hasher is a type that implements build hasher trait. Okay, build hasher trait. And traits will be on chapter 10. Okay. Okay. So I think that took longer than expected. Yeah, but it's good to review once again so that we can remember. So we stick through the program where we try to learn day by day Rust. Okay, so now let's move on to the topic for today, error handling. Errors are a fact of life in software, so Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. This requirement makes your program more robust by ensuring that you'll discover errors and handle them appropriately before deploying your code to production. Rust groups errors into two major categories, recoverable and unrecoverable errors. For recoverable error, such as file not found error, we most likely just want to report the problem to the user and retry the operation. Okay, so file not found is one example of recoverable. While unrecoverable errors are always some symptoms of bugs, such as trying to access a location beyond the end of an array. And so, we want to immediately stop the program. Most languages don't distinguish between these two kinds of errors and handle both in the same way, using mechanisms such as exceptions. Rust doesn't have exceptions. Okay. Rust doesn't have exceptions. So how do we handle error if we don't have exceptions? Instead, it has the type result. TE, okay. For recoverable errors and the panic macro that stops execution when program encounters an unrecoverable error. So for recoverable, it's going to be result. But for unrecoverable, we make use of the panic macro. It will stop execution. Because unrecoverable errors are always symptoms of bugs. And so we want to immediately stop the program. Okay, so that's how it is in Rust. Anything unrecoverable, just stop using the panic macro. Okay, this chapter covers calling panic macro first, and then talks about returning result values. Additionally, we'll explore considerations when deciding whether to try to recover from an error or to stop execution. Okay, so first topic, unrecoverable errors with panic. Sometimes bad things happen in your code, and there's nothing you can do about it. In these cases, Rust has a panic macro. There are two ways to cause a panic in practice. By taking an action that causes our code to panic, such as accessing an array past the end, or by explicitly calling the panic macro. In both cases, we cause panic in our program. By default, these panics will print a failure message, unwind, clean up the stack, and quit. Okay. So by default, panic will print a failure message, unwind, clean up the stack, and quit. Via an environment variable, you can also have Rust display the call stack when panic occurs to make it easier to track down the source of panic. C. Unwinding the stack or aborting in response to panic. By default, when panic occurs, the program starts unwinding, which means Rust walks back up the stack and cleans up the data from each function it encounters. However, walking back the cleaning up is a lot of work. Rust therefore allows you to choose the alternative of immediately aborting, which ends a program without cleaning up. Memory that the program was using will then need to be cleaned by, okay, so yeah, because if you abort, then it will be cleaned up by the operating system. If in your project you need to make the resultant binary as small as possible, you can switch from unwinding to aborting upon panic by adding panic equals abort. Okay. So this is another way of making your binary as small as possible. Okay. So aside from the dash dash release, then you need to consciously put in panic equals to abort so that you won't have some unnecessary unwinding logic inside the code. So how do we do that? In the profile.release sections in your cargo.toml. For example, if you want to abort on panic in release mode, add this abort. Okay. Let's try calling panic in a simple program. Panic, crash and burn. Crash and burn. Oh. I think this is reference to the movie. When was that movie? I think 1994, 1995. Let's see. Crash and burn. I think that is Hackers movie. Hackers. Yeah, 1995. Hackers movie. Movie. Call sign. Here. Jade Murphy is known as Crash Override and Zero Cool, while Kate Levy is Acid Burn. So I think one of the characters said, yeah, so Crash Override combined with Acid Burn, then it becomes Crash, Crash and Burn. Okay, let's get back to this. Maybe what we can do, we can create a new project here called error handling. Handling and yeah, so that's the hello world, and then go the capital, go the tunnel, and we add something here. Profile that release panic equals work. Wait. We need to compare the binary. That's how we comment it out. Maybe not. not delete it. Cargo build. Oops. Cargo build dash release this profile. So target this, then error. That's it. 425352. Okay, take note. 425352. Not source, but cargo. Done. And to port. Okay, 425352. Let's see. Cargo dash release. Okay, then let's show how big is it. 425352. Okay, so it's smaller. So this one 420. So that's 5,000 bytes more. Yeah, roughly, almost. Okay. Panic. Okay, so if we run this, let's see. So run. Tap. Oh, we haven't changed anything. Ah. Panic crash. Sure. Cargo run. Okay, thread main panicked at line 2, column 5. Crash and burn. Note, run with Rust backtrace equals 1 variable to display backtrace. The call to panic passes an error message contained in the last two lines. The first line shows our panic message and the place in our code. Okay. In this case, the line indicated is part of our code, and if we go to the line, we see panic macro call. In other cases, panic macro call might be in a code that our code calls. And the file name and the line number reported by the error message should be someone else's code where the panic macro is called, not in the line of our code that eventually led to the panic call. You can use the backtrace of the functions the panic macro call came from to figure out the part of our code that is causing the problem. To understand how to use panic backtrace, let's look at another example and see what it's like when a panic macro call comes from a library because of a bug our code instead of from our code calling the macro directly. Let's take a look at another example and see what it's like when a panic macro call comes from a library. Okay, comes from a library because of a bug in our code, instead of from our code calling the macro directly. Okay. Okay. So let's see if we copy this one and mm, copy. Okay. Here. Panicked at main RS for 1, 2, 3, 4. Okay, so it panicked somewhere here. Column 6, index out of bounds. The len is 3, but the index is 99. Okay, so we specified 99 here, but we only have 3. Note run with Rust backtrace 1 plus 1. Environment to backtrace. What can we do? Okay. In C, attempting to read beyond the end of the data structure is undefined behavior. It might get whatever is at the location of the memory that would correspond to that element in the data structure, even though the memory doesn't belong to the structure. This is called buffer overread and can lead to security vulnerabilities. Attempting to read beyond the end of the data structure is undefined behavior. Like get whatever is at the location in memory, the data structure. It's buffer overread. If an attacker is able to manipulate the index in such a way as to read data, they shouldn't be allowed to that is stored after the data structure. Okay, so yeah, so you'll force it to access the index beyond what was initially defined. Then you get something somewhere. You manipulate the index. Okay, so whatever that is stored after the data structure can be accessed. To protect your program from this sort of vulnerability, if you try to read an element at an index that doesn't exist, Rust will stop execution and refuse to continue. Let's try it and see. Yeah, so this is the output. 4. Okay, note. Line tells us that we can set the Rust backtrace environment variable to get a backtrace of exactly what happened to cause the error. A backtrace is a list of all the functions that have been called. Oh, then it sounds like stack trace also. Okay. Backtraces in Rust work as they do in other languages. The key to reading backtrace is to start from the top and read until you see files you wrote. Okay, files you wrote. That's the spot where the problem originated. The lines above the spot are code that your code is called. The lines below are code that called your code. These before and after the lines might include core Rust code, standard library code, or crates that you're using. Let's try getting backtrace by setting Rust backtrace environment to a value except 0. Then what was the backtrace value here? Full. Full, okay, full for a verbose backtrace. Okay. How do we set the environment variable? In Ubuntu, that would be is it set? And let's echo. No, okay, it's export. Can echo. Yeah. So export. Then let's do a cargo run. Now we have more things to read. Oh, it's quite long. Stack backtrace, stack backtrace. Okay. What about if we shorten it? Export to maybe just 2. Okay. Some details are omitted. How about if I just set it to 1? And 1 and 2 similar. What's the difference? See any difference between 1 and 2? All ones, 7, 7. But full goes all the way to 38. Can we set it to maybe 14? Let's see. 14. Doesn't seem to change anything. Let's just put 1 for now. Okay, that's a lot of output. Exact output you see might be different depending on your operating system and Rust version. In order to get backtraces with this information, debug symbols must be enabled. Debug symbols are enabled by default when you do cargo build or cargo run without the release flag as we have here. Okay. Debug symbols are enabled by default. Okay, then about if we do a cargo run / release, what will happen? So it's a stripped down version. And then you see core dumped. I think this is because of the cargo tomo specified abort. Aborted. Okay, so what will happen if we release. Okay, so now we see some difference. Here it was aborted, here some details are omitted. Yeah, but it did not abort this one. So because of that setting, profile release, panic, abort, yeah, so it aborted it, and then I thought backtracing will not be executed. Yeah, by core dumping, backtracing was not executing. Here, how do we see that Rust tries to backtrack first before finally aborting? Okay, let's see from here. So I'm just reverting things here. Oops, Recoverable. Hmm. Okay. Okay. Just reverted everything. Okay, welcome back to panic. And then you should and should not use panic to handle error conditions in the to panic or not to panic section later in this chapter. Next, we'll look at how to recover from an error using result. Okay, so let's move on to result. So most errors aren't serious enough to require the program to stop entirely. Sometimes when a function fails, it's for a reason I can easily interpret and respond to. For example, if you try to open a file because the file doesn't exist, you might want to create the file instead of terminating the process. Okay, call from handling potential failure with result in chapter 2 that the result enum is defined as having two variants, OK and ERR as follows. So result is an enum that takes on a type. This I'm not sure. E is a type also, passed on to error, it seems. Okay. The T and E are generic type parameters. Okay, so that's how we should read it. Generic type parameters. Generics in chapter 10. Okay. What you need to know right now is T represents the type of the value that will be returned in success case with OK. Okay, so this is the type that will be returned in success case or happy scenario, happy case. And E represents the type of an error that will be returned in a failure case with an ERR variant. Okay, because result has these generic type parameters, we can use the result type and the functions defined on it many different situations where the success value and error value we want to return may differ. So that's quite lengthy. So success and error value may differ. Okay. Let's call a function that returns a result value because the function could fail. In listing 9-3, we try to open a file. Okay, so standard library, fs file. Okay. Main let greeting file result equals file open hello text. Okay, so let's copy this first. This time I'll use Visual Studio Code. Is it there originally? Multiple files open. So we don't have hello text. What will happen? So we panic. Compiling error. Okay, unused variable, that's a warning. It's okay. Yeah, but we did not do anything. Okay. So here, let's see. fs file handle. Type of used in the error value is standard library IO error. Okay. IO error. Yeah. So here we can see these things in Visual Studio Code, but in VI we cannot see. File is of course standard library fs4 file system perhaps. Okay, this return type means a call to file open might succeed and return a file handle. You can read right too. Okay, file open functions. So this information is exactly what the result enum conveys. So file open returns IO result. Okay. Let greeting file match greeting file result. What happened here? So match greeting file result. And there. So result will have OK and err, so it has to be specified here with a cat arrow. File is used here, while error is displayed here. So greeting file, okay, so this is a new variable because this one is greeting file result, so there's no issue. So this match will return panic. It will return a panic. Panic will be here in greeting file. Okay, so let's copy this. This is fine. It's a warning because we did not use greeting file after line 14. Okay. So here, yeah. So it returned panic because we cannot find the file. So it's like we did handle the error here, and then we just handled it like a panic macro in the end. Explicitly. So what I was trying to do before we read the explanation is to just do a quick check by yourself, your understanding of the what was implemented here. So it's just to evaluate whether if we have learned something in the past few days. But in most cases, there are surprises along the way, just like the vector the other day. So there are some exceptional cases where only when if you really understood Rust, how it works, or based on the documentation, then your assumptions might be wrong. Okay, so let's read through and see if our understanding was correct. Option enum, the result enum and its parents have been brought into scope. Yeah, by this one. By the prelude, so we don't understand prelude yet. That is totally fine. We'll get to that in the next chapters. So we don't need to specify result. Yeah. So I think it's a way where you don't need to explicitly, how should we call this? Use a module, although it's from the result is from, let's see again. Result was from, yeah, also standard library, but it's under IO error. So the preload has something to do with that. Before the OK and ERR variants in the match arms, yeah. Result. This one. Okay. When the result is OK, this one, the code will return inner file value out of the OK variant, and then assign that file handle value to the variable greeting file. Yeah, so this will be returned here if we have below the text. After the match, we can use the file handle for reading and writing. Okay. The other arm match handles a case where we got an error of file open. In this example, we've chosen to call panic macro. If there's no file name hello.txt in our current directory, and we run this code, we'll see the following output. Yeah, but it's just an example. We don't need to put in panic macro. Maybe we can just quietly terminate the program, do something else, yeah, aside from handling the file. Matching on different errors. Okay, so panic matter y file open failed. However, we want to take different actions for different failure reasons. If file open failed because a file doesn't exist, we want to create the file and return the handle to the new file. If file open failed for other reason, for example, because we didn't have a permission to open a file, we still want the code to panic in the same way it did in this thing 9-4. Okay, so we'll improve the code a little bit. That's what it was trying to say by handling. We create a file if the file doesn't exist. I mean, at least if the running application has access to file system directory, and you should at least create a file. Okay. So here it uses match error. Okay, using this error dot kind. Error kind not found. Okay, so these are the different the way I see it, it's like when you do a try catch, these are the exceptions. Yeah, it looks like these are the exceptions, and based on this kind not found, you execute something, fat arrow, execute something, and then it's doing another match. Oh, a match within a match, no, a match within a match within a match. Okay, so now 3 levels. Not found, match, file, create, hello. Okay, and if it's allowed to create a file, it will return FC. So what does it mean? FC will I'm not sure. FC will be returned all the way up to greeting file, perhaps. I think that's my assumption. So greeting file, instead of having a file, greeting file will have FC. While error, E, okay, so E, I think it's like exception, and then you have the instance of the exception, where you can display the exception message or the exception, the entire exception class or object, perhaps. Okay, so since this is a match for this one, create will return result, but match error kind is only not found. That's why we have the underscore here, meaning other than not found, this is how we are going to handle it. Panic. So it will panic. Yeah. And then panic will be returned to greeting file. I mean, that's my understanding here. So I hope you got that yourself also. I'm not sure if it's the same, but let's read through. The type of the value the file open returns in error variant is IO error. IO error, okay. File open, IO error, okay. So this is IO error, which is a struct provided by the standard library. The struct has a method kind that we can call to get an error kind, error kind. The enum error kind is provided by, okay, and has variant, okay, provided by standard library, but in this case it was explicitly mentioned here, use error kind. So It means that it's not included in the prelude. That's why you have to do it here. Okay. Yeah, so although it was not mentioned here, but that's how we would interpret it based on the previous knowledge that we have for file. File is also not included in the prelude. But we also have an inner match on error kind. Okay, a condition we want to check in the inner match is whether the value returned by error kind has not found variant of error kind. Okay, it will create because file create could also fail. We need a second arm in the inner match. Okay, this can also fail. So the second arm will have the okay and error. Yeah, so if this fails, panic. If this fails, aside from not found, panic. Okay, so that's the understanding. That's a lot of match expression. Okay. So there's another way. Yeah, we have the if. We can use if. I think we have if let in the previous chapters. Let's see how we can improve the logic. Okay, so here's another way to write the same logic. Okay. Now, okay, so another concept here, closures, which we don't know. Oh, so many things piling up. I hope we can reach that part also. Oh, may not be so soon. Yeah, but it's just another option. We can still program something using what we know, using match. May not be that elegant as compared to closures, but yeah, for sure we will be able to program something. Okay, let's see. Hello text, unwrap. Unwrap or. Okay, unwrap or else. I think we have encountered this previously in the vector also. Or was it vector or hashmap? I think hashmap. Unwrap or else. Now there's this pipe. I think it's difficult to remember. Yeah, but let's add this into our vocabulary. There's pipe, error, pipe. Okay, let's see. Okay, come back to this example after you've read chapter 13. Okay, so we can skip this. No need to uh, complicate things for now. Yeah, we'll come back to that. Shortcuts for panic on error, unwrap and expect. Using match works well enough, but it can be a bit verbose and doesn't always communicate intent. The result type has many helper methods defined on it to do various more specific tasks. The unwrap method is a shortcut method implemented like a match. Okay. If the result value is okay, variant, unwrap will return the value inside the okay. If the result is variant, unwrap will call the panic. Then this is much simpler. Yeah, just do an unwrap. To run this code without the hello text, you'll see an error message from the panic call unwrap method makes. Yeah, so that simplifies things. You can use unwrap. So let me copy this. Copy here. Copy. And here. so it will call panic. Okay. Similarly, the expect method lets us also choose the panic error message. But this time I think it accepts syntax of expect. So let's copy this also. This one. Yeah, so it will call panic also. And then it displays, where is it? Hello text should be included in this project. Where is it? It's here. Hello text should be included in this project. Okay. Either unwrap or expect. Yeah. Propagating errors. When a function's implementation calls something that might fail, instead of handling the error within the function itself, you can return the error to the calling code so that it can decide what to do. Okay, so it means you pass it over to somebody who will handle it. So it's propagating the error. Okay, so let's see. Maybe let's just do some analysis here. Anyway, we already know the flow. Hello, the text, username. Okay, return error. Return error. Okay, so it returns the error. So that mut username is new, username file is used, read to string, mut username, read to string, username. Username file. What is this read to string? Function, okay. So the file open function and the read to string method, okay. Okay, let's see. Where were we? So it says here that the function can be written in a much shorter way. It's the function. Okay. Read username from file. Read to string. Which function is it referring? But we're going to start by doing a lot of it manually in order to explore error handling at the end. We'll show the shorter way. Let's look at the return type of function first. Function first. Yes, function first. Result string IO error. Oh, I think it's referring to this first function. Okay. Result string IO error. Okay. This means that the function is returning a value type result. Okay. That is clear. Where the generic parameter t has been filled in with concrete type string. This is t, and then you have error. If the function succeeds without any problems, the code that calls this function will receive an OK value that holds a string. Okay, so either way, I think it will return OK. User file result. Username file result. Okay. The username that this function read from the file. Okay, the username. So here, if everything is okay. If this function encounters any problems, the calling code will receive error value that contains more information about what the problems were. We chose IO error as a return type of this function because that happens to be the type of the error. The value we return from both the operations we're calling in this function's body. That might fail the file open function read to string method. Okay, so if it fails here, then we have like an error being returned also. Okay. I think this is quite a long read. Okay, so I think the key point here is pattern of propagating errors is so common in Rust that Rust provides a question mark operator to make this easier. Okay, so how did it simplify things? Use the question mark operator. Here. Okay. So user file for hello text and username. Okay. So by calling username file, if this returns file, read to string the username. Oh, there's a question mark here. Read username from file. That has the same functionality as listing 9-6. But this implementation uses the question mark operator. Okay. Question mark operator. What happened in the username file read to string? Oh, so this section here was replaced by, okay, this part was replaced by a question mark. Or was it only referring to error? Question mark for the question mark. Yeah, I think this is only for the error. Okay, because we can still see okay here, which is actually returned to this function. Yeah, okay, username is returned to this function is everything is okay. Yeah, but this one will return an error instead. Okay. I think that simplifies things. Read to string. Okay, here propagate whatever error I have here. Propagate it up. Yeah. The question mark placed after a result value is defined to work in almost the same way as the match expression we defined to handle the result values in listing 9-6. If the value of the result is an OK, the value inside OK will get returned from this expression. Okay. Okay. Yeah. Okay. Everything okay. Yeah. And the program will continue. If the value is an error, error will be returned from the whole function as if we had used the return keyword. So the error value gets propagated to the calling code. So it will be propagated to the calling code. Okay, so it's like this question mark has some magic going on behind it, handling errors. When the question mark operator calls the from function, the error type received is converted into the error type defined in the return type of the current function. Okay, question mark operator calls the from function. The error type received is converted into the error type defined in the return type of the current function. It's quite lengthy. This is useful when a function returns one error type to represent all the ways a function might fail, even if parts might fail for many different reasons. Okay. Useful when a function returns one error type. One error type to represent all ways a function might fail. Yeah. So that's the purpose. Error, error. Error type, error type. For example, we can change the read username from file function in 9-7 to return a custom error type name or error that we define. Okay, read username from file. So if we change it to our error, okay. To construct an instance of our error from IO error, then the question mark operator calls in the body of read username from file we call from and convert the error types without needing to add any more code to the function. Okay, so without needing any more code to the function. So does it mean this one will also return our error? Yeah. Okay. Same thing applies to question mark at the end. The question mark operator eliminates a lot of boilerplate. Okay. It's a relief. It makes this function implementation simpler. You could even shorten this code further by chaining method calls immediately after the question mark is shown. What has changed here? Okay, error, username. Okay, username, then file, okay. So it started with file, we're just opening a file, then read to string, the username. Okay, so here, error is propagated. If it's okay, then you do a read to string. Essentially, we use the username here, question mark, and return OK username. This is definitely better. Yeah, but we need to understand this one. So it's like the way I see it, it asks the question, can I open hello.txt? Can I? If it's okay, then I can read to string. But can I read to string the username? If it's okay, return username. If it's not, then it will return the error. The result will be error. And one good thing here is we managed to, I mean, not we, but the example managed to remove another variable from the heap. Yeah. So this simplifies the code, definitely. Or is there a way we can just put string new here? Okay, why don't we try that one? Yeah, I mean, that's the purpose of why we are doing this together. Aside from the book, from this one, let's try to experiment together. Bit here. Just out this out. This out. This out. This out. Oh, and then we don't have a main. And why we already have it there. Okay, so what's going on here? What is it that I wanted to do? Yeah, we can use read username from file just to execute the code. And then, of course, this will work. Yeah. Error variant, it should be handled. Yeah. Anyway, we did not handle the error from here. So we are propagating it up. That's the purpose of that. But what I wanted to do is, instead of username, can simplify this further by moving this and putting in string colon new. This one I can comment on. Of course, it will complain, as now we don't have username. Username. We don't need to pass in the username actually. So just something like this. It's just going to be okay. Oh, type string is missing. Can it be string literal? Argument is incorrect. So let's put in me and oh, it's not like this. Should be so no semicolon at the end, meaning we are returning the value to this one. And here maybe we can do like that. Username. Let's do a debug macro just to display and here, since this is complaining, I think we need the reference not percent not. And so to free up this one, but we ended up creating another string here. Should be fine. Let's see. Yeah, so it's not username because it's propagating the error, which shows the error time not found in such file or directory. Yeah. Okay. So I think that was the explanation. Okay. Oh, we can even make it shorter. Wow. Read to string. SFS. FS read to string. Opening and then reading the file. Reading the file into a string is fairly common operation, so the standard library provides read to string. Opens a file, creates a new string, reads the contents of the file, and puts the contents into that string and returns it. Yeah, but we need the username. Read to string doesn't give us the opportunity to explain all the error handling, so we did it the longer way first. Okay. Okay. Yeah, I mean, this one is sufficient enough, but since we wanted to do error handling, so we are dissecting the return of some of the functions with to string. Yeah. Where the question mark operator can be used. The question mark operator can only be used in functions its return type is compatible with the question mark it's used on. This is because a question mark operator is defined to perform an early return of a value out of the function, in the same manner as the match expression we defined in listing 9-6. Match was using result value. Early return arm returned an error. Because it's result and both of them are returning error. It has to be a result so that it's compatible with this return. Now, let's look at the error we'll get if we use question mark operator in the main function. Where's the question mark? Here. Okay. Yeah. So that will not work. Follows result value returned by file open. But this main function has a return type of this one. Main, yeah. We forgot that main is also a function, but it's returning empty. Oh, is it possible that main can return something? Here. I can do something like this. Main return result. Why is it box? Why is it box? Okay, so result is returning empty, comma. Oh, so I think this is the type of error that you want to return. I don't know. I think this will just confuse us further. You have two choices. One choice is to change the return type. Okay, yeah, so that was our assumption. Return type of your function to be compatible with the question mark operator, as long as you have no restrictions preventing that. The other choice is to use a match or one of the result to handle result T. and E in whatever way is appropriate. Yeah, so if we recall, question mark is to propagate the error. But if by propagating the error we end up doing something more, then we might just handle it also like a result like this. The error message also mentioned that question mark can be used with option T. Oh, we use with option T values as well as with using question mark on result. We can only use question mark on option in a function that returns option. The behavior of the question mark operator when called on option T is similar to its behavior when called result. If the value is none. Now, because option you have some and none. So none is like the handling of the error. The none will be returned early from the function at that point. If the value is sum, the value inside the sum is the resultant value of the expression. Ah, interesting. Yeah, so here I think this is sum or none. Text line. It's iterating through the lines of text issue. Yeah. The question mark extracts the string slice. I think this is just the explanation. But what I'm interested in is, aside from option and result, we can create our own structure as well. So that the behavior of this operator can be applied into the structure, or not structure. I think it should be enum. Yeah. Because enum you need to handle both. Well, structure is to represent the data type. Yeah, so let's see. I'm quite excited how far we can go with this question mark operator, because now we are seeing this simplifies the error handling. Quite nicely. Yeah. Okay, says here, vaccine, value, error vaccine, because, okay. This one just explained that there's another error type. Okay. Executables written in C returns integers where they exist. Programs that exist successfully return an integer 0, and programs that error return some integer other than 0, -1 or -1. Rust also returns integers from executables to be compatible with this convention. Okay. So I assume that no error is 0. The main function may return any types that implement termination trait, which contains a function report that returns an exit code. Consult the standard library documentation for more information on implementing the termination trait for your own types. Now that we have discussed the details of calling panic or returning result, let's return to the topic of how to decide which is appropriate to use in each cases. Okay. To panic or not to panic. So how do you decide when you should call panic? My understanding, panic is for unrecoverable errors. When should you return result? Result is for recoverable errors. When code panics, there's no way to recover. Could call panic for any error situation. Yeah, but this is up to the programmer or the developer. There's a possible way to recover or not, but when you're making the decision that a situation is unrecoverable on behalf of the calling code, when you choose to return result value, you give the calling code options. Calling code could choose to attempt to recover in a way that's appropriate for the situation, or it could decide that an error value in this case is unrecoverable, so it can call panic and turn your recoverable error into unrecoverable one. Therefore, returning result is a good default choice when you're defining a function that might fail. Okay, so I think this is the suggested approach. So if you're creating a library, returning result is a good default choice because you are giving that freedom to the one using your library how to handle and not just simply throw a panic. In situations such as examples, prototype code, and tests, it's more appropriate to write code that panics instead of returning it. So let's explore why, then discuss situations in which the compiler can't tell that a failure is possible. But as a human can, the chapter will include some general guidelines on how to decide whether to panic in library code. Wow, nice. So it's like a best practice. Best practice once again. So examples, prototype codes, and tests. When you're writing an example to illustrate some concept, also including robust error handling code can make example less clear. In examples, it's understood that a call to a method like unwrap that could panic is meant as a placeholder for the way you want your application to handle errors, which can differ based on what the rest of your code is doing. It's understood, okay, this statement, it's understood that a call to a method like unwrap that could panic is meant as a placeholder for the way you want your application to handle errors which can differ based on what the rest of your code is doing. Placeholder. Okay. Similarly, the unwrap and expect methods are very handy when prototyping. Before you're ready to decide how to handle errors, they leave clear markers in your code for when you're ready to make your program more robust. Okay. Unwrap and expect. Okay. If a method call fails in a test, you want the whole test to fail, even if that method isn't functional, even if that method isn't the functionality under test, because panic is how a test is marked as a failure. Calling unwrap or expect is exactly what should happen. Yeah, yeah. Unwrap is you are already assuming what you would want to happen. Yeah, but if you use panic, then it is to indicate that something happened here, something big. Cases in which you have more information than the compiler, it would also be appropriate to call unwrap or expect when you have some other logic that ensures the result. Value that you need to handle. Whatever operation you're calling still has the possibility of failing in general, even though it's logically impossible in your particular situation. If you can ensure by manually inspecting the code that you'll never have error variant, it's perfectly acceptable to call unwrap. And even better, to document the reason you think you'll never have an error variant in expect. Okay, so here IP address is this one. You're parsing it. Expect hard-coded IP address should be avoided. Should be, not avoided, but should be valid. We're creating IP address instance by parsing hard-coded string. We can see that 127 is a valid IP, so it's acceptable to use expect here. However, having a hard-coded valid string doesn't change the return type of the parse method. We still get a result value. And the compiler will still make us handle the result. Yeah. As if error is a possibility because the compiler isn't smart enough to see that this string is always a valid IP address, although this is a compile time. If the IP address string came from a user rather than being hard-coded into the program, and therefore did have a possibility of failure, we definitely want to handle result. Yeah, because the user can put in anything. Maybe put in the domain name, or maybe miss out one. Okay. So mentioning the assumption that this IP address is hard-coded will prompt us to change expect to a better error handling code if in the future we need to get IP address from some other source instead. Okay, so here, guidelines for error handling. It's advisable to have your code panic when it's possible that your code could end up in a bad state. In this context, a bad state is when some assumption, guarantee, contract, or invariant has been broken, such as when invalid values, contradictory values, or missing values are passed to your code. That's one more of the following. Bad state is something that is unexpected as opposed to something that will likely happen occasionally, like a user entering data in the wrong format. Your code after this point needs to rely on not being in this bad state, rather than checking for the problem every step. There's not a good way to encode this information in types you use. We'll walk through an example of in chapter 18. If someone calls your code and passes in values that don't make sense, it's better to return an error if you can, so the user of the library can decide what they want to do in that case. However, in cases where continuing could be insecure or harmful, the best choice must be called panic. An alerted person using your library to the bug in their code so that they can fix it during development. Similarly, panic is often appropriate if you're calling an external code that is out of your control. So this is more like the general guideline. Calling external code that is out of your control and it returns an invalid state that you have no way of fixing. However, failure is expected. It's more appropriate to return a result than to make a panic. Example include a parser being given form data or an HTTP request. Yeah, HTTP request is also external, but by returning a status, I think we can handle the true result. Okay, let's decide how to handle. When your code performs an operation that could put a user at risk, if it's called using invalid values, your code should verify the values are valid first and panic if the values aren't valid. This is mostly for safety reasons, attempting to operate on invalid data, which can expose your code to vulnerabilities. This is the main reason the standard library called panic if you attempt an out-of-bounds memory. So that was the buffer overflow. Trying to access memory doesn't belong is a common security problem. Functions often have contracts. Their behavior is only guaranteed if the inputs meet particular requirements. Panicking when the contract is violated makes sense because contract violation always indicates a color-side bug. And it's not kind of error you want calling code to have explicitly handled. In fact, there's no reasonable way for calling code to recover. The calling programmers need to fix the code. Contracts for a function, especially when violation will cause a penny, should be explained in the API documentation for the function. Yeah. So if we are calling a library and it caused a panic, then we need to know and understand somewhere in the API documentation why it panicked. However, having lots of error checks in all of your functions would be verbose and annoying. Fortunately, you can use Rust's type system, and thus the type checking can be done by the compiler to do many of the checks for you. Yeah, so it's already there in Rust. Type checking is already done. If your function has a particular type as a parameter, you can proceed with your code's logic knowing that the compiler has already ensured you have a valid value. For example, if you have a type rather than an option, program expects to have something rather than nothing. Your code doesn't have to handle two cases for some and none. So that's for option. It will only have one case for definitely having a value. Code trying to pass nothing to your function won't even compile. So your function doesn't have to check for that case at runtime. Another example is using an unsigned integer such as u32, which ensures parameter is never negative. Okay, creating custom types for validation. Let's take the idea of Rust type system to ensure we have a valid value one step further and looking at creating a custom type for validation. Recall the guessing game in chapter 2 in which our code asks the user to guess a number between 1 and 100. We never validated the user's guess between those numbers before checking it against our secret number. We only validated that the guess was positive. In this case, the consequences were not very dire. Our output of too high or too low would still be correct. Yeah, it's only validated that the guess was positive. But it would be useful to enhance to guide the user toward valid guesses and have different behavior. The user guesses a number that's out of the range, so actually the range was not considered. Versus when the user types, for example, letters instead. They type in letters. One way to do this would be to parse guess as an I32 instead of U32 to allow potentially negative numbers, and then add a check for the number being in the range like so. Okay, let's see. So there's a loop. Guess is I32, match, guess, string, parse. So if it can be parsed as I32, then it guess would contain a number. Error. So it will continue. Okay. If guess is less than 1 or guess greater than 100, so the number will be between. Okay, so this is where it was match. If expression checks whether a value is out of range, tells the user about the problem. It calls continue to start the next iteration of the loop. Yeah, of the loop. And ask for another guess. If the expression we can Proceed with the comparisons between guess and the secret number, knowing that the guess is between 1 and 100. However, this is not an ideal solution. If it were absolutely critical that the program only operated on values between 1 and 100, and it had many functions with this requirement, having a check like this in every function would be tedious and might impact performance. Instead, we can make a new type in a dedicated module and put the validations in a function to create an instance of the type rather than repeating the validations everywhere. This is good. That way, it's safe for functions to use the new type in their signatures and confidently use the values they receive. Okay, so here shows a way to define a guess type that will only create an instance of guess if the function receives a value between 1 and 100. Guess a value. Okay, but this is integer. Integer is signed. Okay, guess new value. Okay, so this is the constructor for guess. Okay, it will return. Okay, when creating an instance, it will already validate. Okay. Okay. So it will not be checking from here. Yeah. Because the instance of guest before you create an instance, it's already checking here. Guessing game. Okay. New. Yeah. Okay. The code in the body of the new function tests value here to make sure it's between 1 and 100. If value doesn't pass this test, we make a panic call here. It will come out. Alert the programmer who is writing the code that they have a bug and they need to fix, because creating a guess with a value outside of this range would violate the contract. Conditions in which guess new might panic should be discussed in its public-facing API documentation. But that is okay. We'll cover documentation conventions indicating the possibility of a panic in the API documentation that you create in chapter 14. Next, we implement a method named value that borrows self. Okay, value that borrows self doesn't have any other parameters and return I32. This kind of method is sometimes called a getter. Yeah, so it's a getter because its purpose is to get some data from its fields and return it. Yeah, self value. This value I32 value is used here. Okay, so value field is by default private. We learned that the other day. To make it public, you need to have the pub in front of it. Pub keyword. Using guess struct is not allowed to set value directly. Code outside the guessing game module must use the guess new. Okay, so value cannot be explicitly set. It has to be from new. Oh, but value is public here. So value can be set. outside the guessing game. Outside the guessing game. Yeah, because of this one. So imagine you have source. This is a module. So if you have a source main and you're using guess, so you can only call new. But you can also call value here because they're both public. No. This is a function which is a getter, but the value here is not public. Okay. Anyway, you cannot set anything here. It's only a getter. It's a public getter. Yeah. Okay. Summary. Rust error handling feature are designed to help you write more robust code. The panic macro signals that your program is in a state it can't handle and lets you tell the process to stop instead of trying to proceed with invalid incorrect values. The result enum uses Rust's type system to indicate that operations might fall in a way that your code could recover from. You can use result to tell the code that calls your code that it needs to handle potential success or failure as well. Using panic and result in the appropriate situations will make your code more reliable in the face of inevitable problems. Now that you've seen useful ways that the standard library uses generics with option and result enums, we'll talk about how generics work and how you can use them in your code. So the key concept is generic. Because option, you have two things inside options, some and none, while result you have okay and error. So how we do that is through generics, which we will cover in the following day. Yeah, so the this one, the guidelines is quite long. Hopefully you get the gist on when to use result or when to use panic as well. Yeah, I think as you gain more experience in implementing libraries modules, then you would have a better understanding on when you can appropriately use or apply these guidelines as well. Okay, so it has been a long session once again, but hopefully you learned something together with me, or maybe you have your own insights as well. It'd be nice if you can send me some comments also. All right, thank you so much.